It says I'm live. It says live. It says you are live. And it says I am live. Let's get the echo. A little echo action. There he is. How about that? Okay, anyway. Very nice. Very nice, everybody. I'm not sure if that chat is going to be our real chat because I started a new stream, so I'm gonna just move it over. We're gonna let's make it max size. This is not a very intuitive way of doing this, but I'm sure there's a better way. But c'est la vie, I think they say. It's often what they say. Quite a common sentiment. I mean, that's fine. Just put it right there. It perfect. That seems good. That seems good. Can I like hide this bar? No. Menu bar. We don't want the menu bar. Nah. All right, whatever. That's fine. I think we're good there. I think we're good. Okay. Oh shit! I didn't finish my French press, so that is over extracted. They say. Coffee. I've got my coffee and I've got some turkey and some arugula in some flatbread. It's going to be an eating stream for the first little bit, and then it'll be over. There I am. Can I not push that off to the side? Can I see concurrent viewers? How do I go to just, pop out dashboard? That's what I want. And then we're going to move this over here. It's going to be one of our things that is existing in this space. Yeah. We don't need that to be so big anyway. Yeah, that's fine, I think. I can still see my memory. I can see my concurrent viewers and all of the other things that I need to see. My control panel, if you will. Okay, so now it's time. So last time we were dealing with an issue where we were trying to implement multiple we were trying to render multiple cubes. Here's the tracer as it stands right now. We got a metallic. It's hard to tell because all that the background is this, this colored background situation. But nevertheless, this is a metallic texture and that it's reflecting pretty much directly, except there's a random unit vector that's applied to the reflection ray, which makes it a sort of a fuzzy metallic material. Again, it's hard to see that, but I feel like it's almost easier to see when the samples are lower. That's one of the reasons that we decided to start implementing metallic textures, is because or not metallic textures, but yeah, it's not any easier to see. multiple cubes. We want to render multiple cubes because we want to actually see these things reflecting off of each other. We also want to see what happens to the performance when we do that. So right now, we're just doing a very naive implementation where, where are we? Where we just we iterate through the intersection test twice. We add some constant value to our ray offset on each intersection, and then try to track what the nearest hit point was. I definitely decided to make a meal before streaming. Now I'm here and I'm like, how thoughtless of me, how inconsiderate. But it's okay. Okay. So, oh, and I didn't set the date ahead. Is it the 31st or is it June now? Date to, oh, well, I actually have that somewhere here, yeah. May 31st. It's May 31st, not 10th, 31st. Maybe I'll just say 31 so I don't have to keep doing that. Otherwise, I'm going to make a mistake eventually. This seems like it needs to be moved up. This is, I suppose, blatant procrastination. But, I mean, what are you going to do? There it goes. That's fine. I suppose it's going to be off again now, though, once I switch over to my other thing, because my other things are differently arrayed. Okay. Anyway, so we're trying to... So right now, we ought to be getting a result, which is 2 cubes. Well, actually, in fact, right now, I thought that the issue was that we weren't rendering any cubes, but I suppose this is... yeah, because this should be JA by the real algorithm, and when we do that, though, we don't get anything. Let's read our notes here. So, oh yeah, we're thinking that something in this pass is changing a value, which we need stable for subsequent passes, which makes sense to me. So let's check that out. There's also apparently some broken face somewhere. Let's look at that. Doesn't look like there is to me. It might be only when there's a when the offset is off, because before we had this set accidentally, which was causing our cube to be offset. Oh, and that is leading to some kind of... Now, of course, I have never rendered this cube outside of this position, so there's no way to say whether this is just an issue with the intersection test or whether it could in fact be an issue with you get the idea, with the with the way that we're doing the 2 cubes. Excuse me. I should probably move this over here. I think, anyway. I don't see why not. It's the main thing. Make it big, and then make it small. Oh, there you go. That's fine, I think. Oh, I should probably honestly keep these here. I wonder if I'm actually able to, because this is going to make alt tabbing difficult, I suppose, but I wonder if I can, like, deactivate one of these, one of those windows in the window manager I'm using. I'm not sure. And chat, anybody who uses the Barry window manager, let me know. Chat, let me know, whether I can cause the tabbing through windows to ignore certain windows. Okay. So add offset to XMM10. 10 is the current ray origin. So 10 is something that we do want to be different. Throughout. R9 is stable. XMM0 is created at the beginning, so is XMM8. XMM7 as well. XMM6 as well. XMM5. XMM6 and 7. What does move stup do? Move stup. Replicate single precision floating values. Duplicate odd index single precision floating values from the source operand to adjacent element pair in the destination operand. Duplicates odd indexed single precision floating point values from the source operand to adjacent element pair. Does it just interleaves it? Should have written a note there, huh? At any rate, XMM4 didn't equal anything before this, so like maybe we should just like let's just see what happens. Let's just see what happens if we PXOR. I'm really sorry if that was loud. I'm going to move this to a different spot. I'm going to move it right here, which will probably result in worse audio. I don't know why. I just apologize to no one. Anyone watching outside of time and space, sorry about that. My microphone fell, to be clear. Okay, so that didn't do anything, which is to be expected. I'm not totally sure still what move stup does. I wonder whether this kind of grabs the odd indexed elements of the source operand and then just copies those elements. I guess that's exactly what it's saying. Duplicate each element into XMM1. Why would I do that to get a this is not really the point here, so maybe I shouldn't think about it for too long, but we're trying to get the max of the max. We're trying to get just the maximum. What is move HLPS? Move packed single precision floating point values high to low. Move two packed single precision floating values from high quad word to low quad word. Okay, so that's going boop. and moved up. So, okay, this is just something clever being done to get the maximum, which seems reasonable to me. Sure, if I thought through it, then it would make sense. I just don't remember. It's crazy how quickly the memory goes, like way quicker than in a C program. I suppose the C program's just much easier to read and remember. There is something just kind of vile about turkey. Okay, so this is the bit that should be JA, J above, because if T near is above T closest, then we want to say, no, we didn't do it. We didn't do it. And, you know, maybe we should, let's try this. Let's try throwing this above there. Oh, T far? Well, let's try that. Sure, why not? Let's try that. Okay. J below, no intersection. F it's below 0. Duh, you know? If T near is above, which means larger than, which means further than T closest, let's make sure. I don't see how it couldn't be, but let's make sure that we're thinking of our rays properly. Yeah, ray origin and ray direction. Yeah. Axis aligned, center at origin. They always return the distance to the closest intersection. The closest intersection, of course, is return the distance to the closest intersection. Why does this one not return that? Why does our box not return that? Second intersection, okay. T near, yeah, T near is the closest intersection. Oh, well, hang on now. T near. Yeah. T near is float. Oh, the distance, I see. Okay, I guess one thing that I'm interested in. Okay, well, here's an no. I'm interested in the idea that maybe the ray origin probably gets used later, and in that case, you know, in that case, it's been moved by the time the intersection is back. Okay, so let's go back to something we were going to do before. Which is we were going to, free for use, XMM13, to do no using it for stored. Okay, we're going to use XMM13. for the current ray origin, and then XMM10 is going to be the stored ray origin. Yeah, give me the stored ray origin. So let's go with sub PS. Let's sub. Okay, sub PS. So let's move into XMM13, XMM10, and then let's do our sub on 13. Anytime we have XMM10, we're going to put XMM13. This kind of makes sense, I think, to be honest. I should probably have checked if this was actually ever used. Well, it certainly gets updated. No, that makes sense. I thought we weren't taking the origin into account when we were coming up with our new hit position. Let's try though for kicks. A bounce max of 1. How about a 0? Okay. Closest to near is 12. So the reasonable thing to do actually really here would have been to just do we didn't do this, we zeroed it out before, but really we should, the reasonable thing to do would be to initialize our closest intersection t to be negative infinity first. And then, that way, anything above negative infinity is a hit. The reason we didn't do that is because we kind of did want to test against the idea that it was 0. So, but we now want to do, yeah, it could be this. This should be a thing. Oh, no, sorry. Okay, we're doing this here. Yeah, okay. Okay, if it's less than, if it's less than, then we do that. Is that so? Oh, ha. Ha. Ah. Oh. What's our bounce? Our bounce is 10. If it's less than, then we calculate the sample color. And what less than means in this case is if we are, equal, you know, if we have not hit something. Let's do a slightly different thing instead for now. And let's instead say v4 negative inf. Basically exactly what we did with the 0 value, and we get the same result there. Okay, so why are we getting, you know, why are we getting a black screen? Hmm. Hmm. Why are we getting a black screen? Let's see if we okay. Okay, so we do make it to that code path. Yeah, we make it to the end of the intersection. So there are moments where we are calculating the normal and all of that stuff. Ah, okay, no, that's fine. That's fine. That's fine. What if we switch our sample count? Let's try that. Okay, we don't want this. Let's do that with the... Okay, we're back there. So we're good. So that's all good. So doing multiple samples is not screwing with us. Although let's keep it at 1 for now. I think that's reasonable. So if it's less than 0, we calculate the sample color. And that does end up happening sometimes. Bounce, trace another ray unless we are at max depth. like, has the ray origin or direction been fucked with? XMM 11. No, dude. Actually, it has. But that's okay, because we don't need it anymore. That's the idea. That's the whole thing here. But and by the time we do that, we're you know, we're done with all this intersection business. And yeah. After all this, we end up going back to trace ray. And at the beginning of trace ray, we initialize all this stuff. It must be a shoddy initialization of this stuff that's going on. Well, no, not must be necessarily, but feels that way a little bit. My thinking is a little bit scattered at the moment. It's not very directed. It's more like a diffuse reflection than a metallic reflection. At this point, has 10 been when we go back to trace another ray? Again, going back to trace another ray actually is not the issue, obviously, because we just set the sample count to 1. Okay, so never mind. You know, never mind. In fact, well, no, right. Yeah, if we set our bounce max to 1. Okay, so this is the situation in which we're getting the black screen. So if we set it to 1, okay, let's set it to 0 real quick. Okay. No. Okay. Well, that's interesting. That's very interesting. Okay, I wonder if this could be... Okay. Okay. I just thought of something. What if we are inside of the box? Well, that wouldn't be the next time, though, would it? Let's make a different thing here. Let's call it box off. Box on, box off, right? Why is this 0.43? Okay, so box on, box off. So box off is going to be none of these things except for that one. I see. Let's go with, as well, let's say, do we have a thing which tests, blah, blah, blah. We're going to do that. We're just going to do one box. Why? Whoa. Okay. We should have tried that before, you know? We should have tried that before. So when there's 10 bounces max, ugh. It's less than 0. Is the ray always less than 0? Well, yes, of course. Sometimes it is. Or no, not the ray direction. It's the t near that we're saying we want less than 0. Oh, wait, no. XMM 12. Oh, no, closest intersection T. God damn. What happens if we just don't do this at all? We just don't even give a shit. All right. All right. Because, yeah, we are getting here as well. Ah. Okay. So closest intersection D. So, okay. One thing that just occurred to me is that we're actually now not using XMM. We shouldn't be using XMM5, but we probably are later on in the algorithm. So, for instance, this, yeah. No. This is fine. This is fine. But any time after this point that we use XMM5, we should be using XMM12, 12, 12. I bet you that's it. That's kind of just a hilariously dumb bug. Okay, that is really interesting. I don't know what this is, but it's very cool. Wow. I want to up the samples of that and see what happens. 16. Nothing much. That's pretty cool. Okay, so where's our bounce? Oh, bounce max is 10. Okay, so we're actually fucked right now. Let's set it to 1, see what happens. Oh, interesting. Okay, let's set it back to 10. Right now we're also only doing 2. Let's compare against both, you know. Whoa. Excuse me. End intersection. Where's end intersection? There it is. If far is less than near, then we did not intersect, so we should just end the intersection and not track the closest T near. These should be together, I think. Okay, so 12 isn't here. Wonder what's going on here. We're using 4. Is 4 is far. Oh, okay, we just got a random normal in 4. Okay, gotcha. Never mind. Maybe the this reflection thing is fucked up. Let's do our diffuse material again. Whoa! Oh my god. What? Huh. Dude. Oh man. Oh, okay. Okay. So one thing is, I changed this to sub, and I probably shouldn't have done that. Let's go to box max. Yeah, actually, this is fair. Okay, it still doesn't do anything. It still doesn't do anything good. We're just fine. And are we still black here? That is so interesting. I wonder why that happens. I do wonder why that happens. B4 box max, B4 box max, blah blah blah. XMM 13 has been done here. So let's just not do this real quick. Okay, still does that. Oh my god, what? Dude, why? Why is that? Why is that? Oh. Okay, so we do want to know, are we properly testing? Let's do this negative. Let's go back to this situation. J equals. Okay, we're back to this. Interesting. Interesting. Very interesting. Let's go back to 2. Seems like I could probably bring my camera slightly down. Might be better. I don't know. It's already 8:45, my guys. Still doing a lot of work. I can hear my CPU going. Ugh. Oh, fuck. Let's go back to the metallic. Nothing. Okay, I wish that I remembered exactly how I got to, Oh, the fuzzy reflection isn't even implemented, dude. Let me bring that back. Okay, it's not back, but, bleh. Before 0. Oh, we're still doing that, right? I do not like that. I do not like that. If T near is less than T closest, go back to our original Okay. Interesting. It's either red or pink. What does that do with the... You make a movie called Flippa. The whale is dead. Died in a car accident. Sorry. I got tickled. I got tickled by it. That's all. It's a good. I think it's a really good approach to assembly comments right here. This is this is it. This is programming. That's going to be a YouTube short. That's going to be a YouTube short. All right, where are we? What's going on? Okay, so we're doing that. Where's my diffuse texture? Let's bring it back. Oh, that was the diffuse texture. Well, let's bring back metallic. Okay. Metallic is very much working, but it's switching. Okay, so get this, you guys. I think we're tracing properly against the rays, but they're not showing up at the right location on screen. The reason they're not showing up at the right location on screen. Well, good point. Good point, everybody. Give yourselves a pat on the back. No, not true. The dog is dead. Died in a car accident. Yeah, if we move the ray, then it should just, fuck, then it should work. Where's box off? Where's box off? Come on. Get your box off, rocks off. Where's my box off? 0.0, 0.5, blah, 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 blah. Let's make it not just that. Dude. Oh my god, dude. Every single time we test an intersection, we're adding to box off. Box on, box off. Box on, box off. I don't know that that even makes sense, Every time we intersect against a box, we're pretending the ray is in a different location, which makes complete sense. We're just transforming the ray, that's all. You'll need to transform the ray origin and direction, says Inigo Quiles. They might just be saying because, you might want to rotate the cube and shit. Let's just see how we're calculating the ray direction, How are we calculating the ray direction? Ray origin from camera position. Ray direction. Okay, so okay, let's do something real quick. Let's do something real quick. I'm just gonna see, okay? I'm just gonna see if doing this also to the camera, to the origin, is also needed. Because part of me can see why that would be. Are we testing against 2? We are, yeah. So we're incrementing R9. Well, first of all, right now, it should be R9D. Okay, that's fine. Doesn't do anything. We're still there. We're still there. Yeah, I guess it doesn't matter whether we're R9 or R9D. Okay, so R13D. You know, puro. I think you've heard of this puro. You know what I mean? You guys know what I'm talking about. You guys know what I'm talking about. You know what I mean? Wait, what am I doing? We're not trying to do XMM10 right now. We're trying to do XMM11. It didn't do anything. It did not do anything. Okay, how are we? Let's actually look at this real quick. We've got, so XMM11 is our X, and then it's our Y. Okay, that's fine. And then it is our yep, okay. It's just the delta along the worldview port. We're adding the X to the Y, so now XMM11 is our X and our Y. We are taking our God damn, yeah. The direction is okay. Sorry, I need to stop being so no, yeah. It really should just be that we just add to the thing. So let's go back to, so this right here was our, and we're back there. Okay, so, and then we're back here. Isn't that something? Isn't that something? Where's our bounce count? Why? Where the fuck is our bounce count? Why is it always so hard to find? Because it's down there. Why? Why is it down there? Okay, only one bounce. 0 bounces. Okay. Okay, so we should be able to do this calculation with 0 bounces, no problem. We should be able to do this calculation with 0 bounces, no problem. So, when we get to, we increment R9D. Oh, God. I think that I'm doing the wrong thing here. Compare to 2, jump if less than. Okay. All right, we got it, boys. We got it, boys. Okay, so that is a very interesting problem, or a very interesting, just embarrassing, frankly, issue. So now but now we have fucked something up. We have fucked something up. First of all, are we set to JB or JA now? We gotta do all this stuff over again here. So let's do we don't want to do this to the direction. Okay, good. Wow, look at that. That's cool. I wonder why there's the weird thing up top though. Where's our box off? Box off is 1.0. What if it's like 2.0? What if it's like 2.0? Huh? What would happen? Nothing good. 1.5? Okay, yeah. 1.25. Okay, cool. Okay, so we've got some sort of odd glitch happening up there. I guess we don't know whether that was perhaps already the case. But this is cool, huh? This looks cool. Does our distance thing work? I'm not sure. It really doesn't. Oh, that's because, okay, I see. The distance just determines the, like, whatever you want to call it. Okay, also, it seems to be... Whoa, look at that. That's pretty fun, you guys. Okay, so we want to be... How do we actually get further away then? I guess let's just make the viewport larger. Whoa, that's infinitely tall. Why is that? Why is that? Anything above a certain amount just ends up fucking green? Let's go back to subbing the thing. Let's try that. Okay, they both end up green. I guess that I don't know if that makes sense, but either way. All right, we should probably fix that other issue as well. That might fix the same issue here. So let's just make sure everything is the way that we think it should be. So this should be flipped around. We still don't have anything at that point, which is, you know, not very fun in my opinion. Not very fun in my opinion. Well, let's see about our this j less than v4 0. Let's try that. Whoa, that is a weird one, huh? If XMM5 is less than 12. Yeah, we really want to just skip it in that case. So I don't know I don't know why. t near is above. Oh, okay, well. That's hilarious. Okay, that's funny. This should be inf, not negative inf. That's interesting. Very interesting. Well, we do want to now test this. We want to say inf. If XMM12 is less than, no. Oh, v40, and then we'll say greater than. It's greater than. JA, okay, if t near is above, then we want to blah, 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 blah. Because we want to keep on moving it closer and closer and closer. So if the nearest is actually higher than the closest, which it wouldn't be if it starts at inf, Oh yeah, and obviously, yeah, this makes no sense at all. So we just need to say inf. Okay, we need to say if it's equal to. Yeah, that makes sense. If it's equal to inf, then it hasn't changed. Okay. Well, we're a little weird here. When we are... Oh, it's only those two faces. Oh, wait, no. 1, 2... Oh, it's all three of those. And perhaps the one on bottom as well. Who knows? Where's our bounce max? Because that could be actually doing a lot here. Oh, bounce max is 16. We're perfectly fine when we're just doing that. Do we think this thing at the top where it's getting larger is normal? Maybe we do? No, of course not. We want that to end at some point. Let's just make, first of all, let's make bounce max something like 8. Let's make it 100. Okay, it doesn't do much. Let's do 8. Let's do, where have I, what was I doing? Let me just see again. What was I gonna do? Oh yeah, okay, let's make our thing larger, like really large. Like 20. Okay, so it does end eventually. Haha. After a very long time, if I'm being honest. Let's normalize. Are we normalizing the look at location? Because let's do that real quick. Well, the basis vectors are normalized. Scaling the viewport height and width by the basis vectors. XMM10 is W. So here, what we do is and 14 is going to end up being the pixel center at UV00, which isn't really actually what it is. It's just the viewport top left that we're making. Oh, focal length. Where's my focal length? Focal len. How about 1? Whoa. That's crazy, dude. That's crazy. Why are we seeing through the cube? Well, we are now at a larger focal length than we are at distance. So let's go 1. That's not too bad. And now let's make our size something more reasonable. Let's make it 2.5. Okay, and then let's make the focal length. Let's make our distance like relatively far away. Distance far away, focal length, focal length. Oh, why is this? Okay, 2.0. Alright, let's switch back to something that's not 2.5. We do want to be a little bit larger. Alright, let's go 5.0. Okay, so the cubes look to be a reasonable... I think before we just kind of had some crazy FOV shits going on here. So, okay, we've just got some weird things happening now. It seems like let's switch back to our diffuse texture and see what happens there. You know, I think to a certain extent, we might just be... Let's normalize the ray direction, actually, just for kicks. Nothing, okay. To a certain extent, I think we're just fucking with the direction, which we really, again, we don't want to do, and we have not done. And again, let's just make sure that's not something we want to do. Let's do it again. Okay. Right. That's what happens when you do that. It's very cool, in a way. It also doubles the offset, which is kind of interesting and makes sense. Okay, so again, let's switch back to the diffuse, because why not? I want to see what that looks like. Might give me some ideas. The diffuse, okay, becomes similarly random. Let's switch back to that. And how many samples are we doing? Let's do a lot. 16, okay, that's actually quite a lot. Let's do 1 then, see what a little does. Okay, it just looks shittier. Let's do 64 by 64. Okay. Is the actual reflection we're getting reasonable? We really need to switch back to a more more zoomed out thing. So let's do distance 4. We'll make our focal length, focal length. 4x3. Everyone loves 4x3. Focal length is how far away the viewport becomes, so that is definitely, yeah, doing that. So let's do, oh god! Well, that should make it more fisheye. More fisheye. Why does that do nothing? Weird. It seems like that should be doing the focal length should be doing the opposite of what it's doing, but I don't know. Yeah, whatever we do, we want to do it at like a 2-ish. Let's do like a let's do 3-ish. Because really, if we want a certain level of fisheye, it's going to be proportional, you know, to that kind of a thing. 2, and then distance ought to be 2, perhaps? Okay. All right, this is reasonable to me. Okay, let's think about our reflection. These reflections make sense. These reflections make sense. Okay, so it's just the other sides that don't make sense. We do know that it's working just fine, or that it was working just fine beforehand. So we did something, and even if we just do one thing now, it ends up being screwed up. Let's do, okay, one thing I do want to do, because I don't think we need to, let's just see here, XMM. Maybe we, maybe we do want, XMM10 to be updated. Because where does it actually get used? This is our actual thing that gets generated every frame, so this is totally stable. And then it like pretty much just doesn't get used again. Okay, it gets used here though. Okay, yeah. So yeah, we should just I think in fact we're screwing ourselves over by doing this. Ah. Ah! Whoa. Okay. Haha. Interesting. Let's again switch back to one bounce. One bounce. Same. Same, brother. This is completely fine. Oh, that's weird. Hmm. Interesting. Interesting. Infinity. Yeah, okay. Infinity. Infinity. So it's starting with infinity. Inverse of ray direction. Five is near. If it's less, if it's above, oh, no, okay. Ha!
Ha! Wow! Ha!
Okay, that's interesting. We need to do what other? All right, I'm going to add a to-do here because it's not the issue that we're dealing with now. Once we figure out noise issue, we need to bring back XMM13 temp so that we can track the closest ray origin of the closest T intersection, because that needs to be the the reason we don't know, or the reason we know that that's not the issue, the reason we know that's not the issue right now is because the same, or the reason we know that's not the issue with the noisiness is because that happens whether we are intersecting against one or all of them. Yeah, so it's even happening down there. What happens with, we'll do 3 again. And then let's switch back to diffuse. Think about that. Okay, so it's all red. It's all red over there. Interesting. Very interesting. It's all red there. Except it's blue on the other side. Let's go to our thing. What do you call it? Let's make our box off here 0.75. That'll make a much bigger difference. And we still have just this one face being blue over there, which is very interesting to me. It's all red other than that. It's all red other than that. And it's not because it's bouncing around a bunch. It's just totally random. In the diffuse case, we're adding XMM11. Yeah. We're adding to XMM11, which is the ray direction, which has never changed, I don't believe. It was before, but we decided not to do that. But we're adding to XMM11 the normal of the intersection. And that should work. Like if we find an intersection, odd that it's not centered. That to me is very odd. It's not centered. Let's figure out how we're getting the normal. What is 12 again? 12 is the closest intersection. Excuse me. Okay. Still happening even when we don't. So we really need to know, what it is that we changed that it's causing this issue. Honestly, maybe I should just do a diff. I might just want to do a diff here. Okay, yeah, that's fine, that's fine. We added all this shit. Makes sense. pixel. Are we XORing? No, we're just doing that. I see, yeah. Okay, yeah, that should be good. Oh, yeah, fair. Okay. Let's bring back this. Let's do it. Let's see what happens. Nothing. As always. I think it's just because the cubes are always in front. If t far is less than t near. Where did that go? There it is. Let's do this as well. I don't know. Whoa! That's interesting. That shouldn't make a difference at all. That's crazy, dude. That is totally crazy that that's happening. What is XMM12 again? It's the closest intersection T. Oh.
Ow! Ow, I say!
Where are we testing these sorts of things? We're testing XMM12 with UCommas. Let's do this real quick, just for kicks. Okay, interesting. Very interesting. Oh. 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 Whoa. Shouldn't make a difference. Shouldn't make a difference. And again, UCommas, single scalar. Yeah, unordered compare. A what? Where's get normal? There it is.
Oh, God! Oh, God! Oh, dear!
That should be 12. It really should be. It should be 12. Ah. 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 Ah.
What? What the fuck?
Okay. Okay. Okay, so the issue is now the position from before. So right now, what we need to do is we need to bring back the XMM13 to check the closest origin. Okay, so let's move this back to XMM13. We're going to say 13. We're going to say 13. We're going to say 13. We're going to say XMM 13. No, XMM 10. Yes, yes. So from here on out, it'll be XMM 10, because we're going to be keeping track of whatever the best one is. Where are we doing that? Oh, we're doing that here. Move APS XMM 10, XMM 13. Not bad, not bad, not bad to be honest. Okay, so right now the most recent one is getting the bone, if you will. Track the ray origin of the closest. We got a ray direction. And that happens every sample. This needs to happen every intersection, perhaps? So this is just correct all around. But that is not. How is it for the metal? Correct only for the last rendered object. Oh, it looks sexy as fuck, though. Oh my god. Because it's actually bouncing. Oh, fuck yeah. Oh, see it bounce. Oh, yeah. Could be that the normals, the stuff we're doing to get the normals or whatever, doesn't work outside of the origin. But that's not true. That's not true. Because if we set it to, let's go back and set this to 1. To 1. Yeah, it works just fine. Mostly green down there, which makes sense. So it totally works. All of the stuff works outside of the origin. Any other place that we're like using XMM10, the direction should never change. 10 is the origin. 13 is the current origin. do one more. Just a kind of a weird axis thing going on. It has to do with... Yeah, the second thing is just screwing up something that we use later. It must be. So, so what do we use later? Well, what do we store now? That's one of the questions. So when we do test an intersection, one of the things we get is the inverse direction, which seems reasonable. We get the negative n, we get k, 76576. We get t near, we get t far. Do we ever use t far? T far. Excuse me. XM4 is considered to be free at this point. So let's first of all, let's look after the intersection testing is done. 12 is the nearest thing, blah, blah, blah. We attenuate the color, which is in XMM9. This is the current color attenuation. Yeah, sure, that's fine, yep. Bounce, trace another ray. We might bounce again, right? And have we set a new position yet? Oh yeah, okay, that we do that after this. Okay, so if we don't yeah, so if we don't if we are at max depth, which is never the case, never mind. Let's go to let's figure out. Let's just make sure that our bounce is set to something really high. It's set to 2. Maybe let's go 16, because actually that could be part of the issue now. It's not, but that's okay. All right. So we've set our bounce max though to something high, which is should get rid of certain issues perhaps at some point that we might run into. XMM12 is now the thing. So we do, okay, we don't use that. Okay, so 7. What is 7? 7 is T1. And that happens after that. Really? Okay. We need to define something a little bit more robust here. And let's see if we can find any more, because we found one already. 12 should be good. 3 just got moved. 8 is just got moved to, that's getting moved to, or whatever. 0, okay, 11 is the ray direction, which is fine, that never changes. XMM 0, we've got that, okay, so that's all good. We have the normal XMM 7 was just created. We just made 6, we just made 4. We're going 6 and 4. Fuzz factor 7. Multiply by 11 and 12 trace array. That's it, I think. Yeah, XMM 9. Okay. All right, cool. So we just need, it's just that T1. So let's go to our T1. Okay, now I understand the ones where it was total random noise were the places where it did not intersect with the other cube type of thing. I don't know, something like that. Okay, so we need to keep track of T1. So right now, we don't need to do anything with this, but the XMM14 is the color sum. Before look from, all right, how many times is 15 used? It's used quite a few times, I think. Oh no, not really. Just that, those 2 times, really. Okay. XMM15 is going to be XMM15. What's 14 used for? I think we already sorted that out. That's, yeah, color sum. So we should probably just make this 15, which is kind of going to be confusing, but blah, blah, blah. That's fine. XMM. Not quite. Cool. All right. Ah, what the fuck? What are you moving around here for? Stop moving around. Ah, you fuck. Close enough. Okay, blah, 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 blah. So then we're going to keep track of the closest T1. So we're going to say XMM15. Oh, never mind. Actually, that does need to be an intermediate value. Yeah. Not 15, 14. There you go. And that is all that she wrote. and we'll go for... We should really turn this into a thing. I'm gonna go 3. Nice. Let's just do a lot of samples just to see. Looks pretty cute. How about 4? It's pretty good. 4 looks pretty good, I think. I like it anyway. I just want to see what a higher res looks like. Oh, fuck. I love the higher res. I do like the higher res a lot. The frame rate could be a lot worse, to be honest with you. Like at this point, it's doing quite a lot, you know. It's doing quite a lot per thing. This is gonna make it really slow, but I just want to see it. Oh fuck, that looks good. Let's go something. See what high sample, low res looks and feels like. Pretty fast. That might be, well, no, we're hitching a little bit. I think 128 by 128 might be my target, but we'll see. Oh, it looks good. It looks good. Let's bring back the absolute value situation here, because I kind of like that as well. Let's see if it looks good. We kind of need to make it 256, let's be honest. Yeah, the absolute value doesn't work, unfortunately. Let's change the albedo at this point. Oh, actually 6.6 is pretty good, but let's make it a little bit yellow. Which is, yeah, red and green. Now let's also, yeah, let's get rid of the absolute value. I don't like it anymore. I just don't love it anymore. Oh, fuck. Might. Let's also... Can we flip the ray? Not really. That would be fun. I mean, we can, but I just don't really want to. Let's just instead move us below so we can see how that looks from beneath. Oh, that's cool looking. There's something kind of badass looking about about the from below. Wonder why that top one is so bright. That seems wrong, doesn't it? I wonder if our bounce maximum is... No, it doesn't really do anything. Yeah, that's kind of weird. Can I... just do that with phi? Oh, hopeful. That looks pretty badass. Oh, jeez. It's a little slow there. I'm gonna be honest with you. We'll make it. Let's start at a different theta. Huh. We always end up, yeah, I guess it'll always be that, which is kind of, yeah, that's too bad. Let's do that. Let's go back to sample count. Let's bring that down to 4. Make it real nice and fast. Yeah, it looks cool. It looks cool as hell, dude. Okay. Something might be wrong, though. God, it looks cool as hell. This is going to be so cool with the dielectric materials as well. Yeah, so, but it seems like it does seem like something's wrong, because it seems like, first of all, let's make the, what do you call it? The, period for the phi twice as long as theta, I think. I think that's the way to go. That way you get both sides during the rotation. Yeah, so when you're looking up at these, it's too bright green. It's too much, too bright, because it should be bouncing like that. And it seems like, yeah, okay, well, the top one is brighter than the others, which almost suggests that it's getting, once it bounces, that like the bounces are seeing the world the opposite. Does that make sense though? It might not make sense, you know? Really, as long as the thing happens the same for everything, you know, it should just be the same world. So maybe it is correct. I'm not sure. I'm trying to see almost also if I see. Let's okay. One thing that'll make this a little easier to see is if we don't. If we let's get rid of the fuzz factor real quick. Let's just get rid of it. Okay. Wow. Okay. Whoa, yeah, look at that shit. Look at that. Okay. Yeah, so this is wrong. Dude, it looks so badass, though. Look at that. Okay. Look at that, dude. Come on. Yes. Oh my god. Come on. Sorry. This is good. This is very, very good. The fact that this is running on a CPU is kind of just crazy. It's like dope. I need to make this slower so I can really think about what's going on. I think it is actually very much straightforwardly just that every reflection is the inverse world. So when we trace a ray, you know, we're offsetting the ray, and then if we hit something, that becomes the new ray origin. And then we transform that ray. Well, I don't think this really makes sense, but let's try doing First of all, what does our diffuse look like? Not enough samples really to make that cool. But okay, so let's try this. Let's try adding instead of subbing. I don't know if that makes sense as a fix, but maybe it does. No, it looks like it's the same, which makes sense, you know. Oh God, look at that. I'm gonna take a break. Yeah. Duplicate. Can I duplicate? Copy, 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 and duplicate. That'll do. I'll let you guys see the beauty. Little bit of a waste of resources. Let's just have it running on a lower. Can I do 128 by 128? Here I come back for more. There's someone viewing the stream, or that's still just me who opened it up for just a moment. Hello. Christ, it's bright, huh? Why is this happening? Why is this happening? I just want to make sure. Yes, okay. Yeah, it's a little bright, huh? The thing is, I'm not able to change. I don't think I can change the exposure on this. Oh, well, it fixed itself anyway. It's fine. No, what? Opening up the settings allowed it to fix the exposure, which, you know, I guess makes some sense. I don't know. All right. Oh, here we are. Okay. Now it says 2 views, which means profit, you know? I've got an apple here. I'll try not to chew into the microphone. So we have a very cool looking image here, but as I stated before, the problem is every bounce, I believe the ray is acting like the reflection. Oh, we have a now floating point precision issues as well. This is what it should look like. But it's acting as if I recall, it's acting as if the point that the new ray origin, when it bounces, is the opposite. Or perhaps it's treating for every bounce, even for, like, say, this one and this one. It's just treating it as if it's the bouncing off of the center cube. It's one of those things. We're still sorting it out. It says that we had some sort of chat, but I certainly don't see it. Yeah, we've placed straps. Welcome back. I don't know why I couldn't see your chat there. There you are. Yeah, we've traced some serious paths. This is our metallic texture. Again, I don't know if you heard my explanation just now, but yeah, it's the bounce is wrong, but it does look very cool. We also got rid of the fuzzy bounce, but let's bring that back so you can see that. Fuzzy texture. Now it's still reflecting, but it's fuzzy. It's fuzzy. But we are disabling that for now so that we can diagnose the issue with the reflection. I'm also going to make this slower. I would like this to be slower. Let's just add a 0 to each of these. There you are. Okay. Okay, 10x slower might have been a little bit of an intense idea. It's not even that it's seeing a mirror world. It's what is it, actually? Whatever it is, I believe it's alternating every bounce. So we can just maybe look at this Because the issue would be once we get back up to, I think, trace ray. No, maybe not trace ray. Sample start. Yeah, actually not sample start. Okay, so trace ray is what we want to be looking at. When we trace the ray, we're back here. And what's interesting is I really feel like it should just work out of the box. It could just simply be that our reflection code is wrong and it doesn't have anything to do with the... Well, no, I think it is correct because if we set our cube iterations down to 1, we do get reflections that match what we would expect. Green is reflecting onto green. As we move further up, we should get some more of the black, you know. And that makes total sense. And behind us would be the red. So, so the reflection itself is correct. It's even correct when we've done some fuckery. Although it would be interesting, I suppose, to note or to check whether if we don't offset this difference, if we have an issue still. So let's just like do that. And I think this does make total sense. Because yellow would be behind us at this point. Black's reflecting off of there. So that's correct. Let's add this back. Move our iterations up to 3. That's interesting. Excuse me, perhaps our ray origin is being set incorrectly. Is he really going? He's going to find some paths, huh? What are they the same nature of path, or what sort of paths do you mean? Ray origin of closest T. Bounce another ray. This comment is confusing. Stop. Stop bouncing rays if we are at max depth. I see. Oh yes, I guess it's Sunday. It's Sunday. which campaign is on today? Yeah. XMM11 is the ray direction, so that should be just fine. The hell game, yes. I've not talked about Blackwater with Alex. Are we barreling towards that happening at some point soon? I'm going to limit this to 1 once we finish up these other games. You've got a time horizon in mind. Yeah, I mean, I'm probably not going to do that. Certainly not anytime soon. You got any idea what's happening here? You got any intuitions about where the ray thinks it is once it bounces off of these guys? Like, is it just being inside? No, it's not. Single bounce is just fine. Oh no, it's a little fucked up. Fair enough. Okay, so we want... Does XMM13 get changed? Oh, well, we're moving... XMM13 is what gets used as the final thing, as the final calculation. And so, in that sense, reflective vector is the new direction. XMM10 is the new hit position. 12 is the closest intersection T. We're going to say T1, closest T1. Closest ray origin. So 12 is the closest intersection T. We are multiplying T near, which should be 11 and 12. Let's just move this up here. Okay, so 11 and 12 are multiplied, the closest intersection, and the current ray direction. And then added to that is the closest origin. And then and then 10 gets moved back into 13 to trace another ray. Well, and then T1 gets recalculated. When does T1 get used? Once the pixel is written to. Doesn't it get written to during the normal calculation? Oh, 14. 14 is closest T1. He's gone. As a tech guy, I mean, if I'm gonna be there as a tech guy, I'm probably gonna be a PC, because why not while I'm there? Sundays are just a good day for me, because a good day for me to do programming and things like that. But we can think about these things. I will think about these things. Someone tell me when XMM14 is used. Used as we're getting the normal. Yeah. And all that gets recalculated once we retrace the ray. Give us free, if you wish. Where is our per second? Data per second. Make it faster. Make it faster. Okay. Where did our bounce iterations? Oh yeah, we want more bounces, please. Okay, it's still weird even with one. Even with one. Well, let's see what it actually is like because with just one, okay. We're still screwed up even with just one. Okay, so that just tells me again that it thinks it's I might have to draw a picture. I might have to draw a picture for myself. I'd have to draw a picture. I'm gonna have to draw a picture. What I'm gonna have to do is I'm gonna have to draw a picture. Oh, here, check this out. Check this out, you guys. Here we go. Now it's for real. We'll go to we'll duplicate this scene, and we'll make this bigger. For all the viewers at home. So, hopefully it's able to. Can we do better on our exposure time? We really can't. We never can. There it goes. Okay, so long, and have fun at Pathfinder. Truly, have the most wonderful of times. Yeah. Shit, I need a better pen. Treg pegs. Okay. Yeah, okay, yeah, Treg pegs. Treg packets. Treg packets, my friend. Oh, we've moved our pens. We've moved our pens elsewhere. Elsewhere. This is terrible. We might be okay here. Okay, so here's our array. It hits here. So in the case of, well, actually, yeah, what's interesting is that there's no mathematics occurring here at all. Let's see, first of all, there is a little bit. Okay, so it still happens even when we're at the origin. That's important to note. Quite important to note. Okay, so it happens even when we're at the origin. So even when there's no math involved, the reflected ray, it's almost like it's almost like the ray position gets, let me just I'm going to move this over here so that there's some level of, you can see the screen, and I'll make sure and put the thing on the other side. Okay, let's make this that again. Jesus, that's fast. That is too fast, way too fast. Let's go ahead and make, oh, that's because it's 0. That is way too fast. Let's go 0, 5 for this one as well, and let's do 2, 5 for that one. Okay. Okay. Where's our mem? We've got 9 gigs of mem. Okay, so let's see. I'm thinking maybe the ray is getting reflected to like here, for instance. And I wonder whether that would account for what we're seeing. Or if it's in fact getting reflected to the other side, like this. So if it was getting reflected to the other side of the cube, let's switch this back to being 1 bounce, or 2 bounces, or whatever the right thing is. I guess 1 bounce, right? Let's do 2 bounces. Okay. Ha 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 ha. Okay, so with one of those, okay, let's switch back to 1 bounce. That might actually make it more clear now that I think about it. All right. So good. Something like that. Okay. Okay, so if it's 1 bounce, what happens? As we're looking down green, the bounce is green, which makes actually sense, as it turns out. So the bounce direction is actually correct, and it's the ray position that is incorrect. Or, like, is the position itself perhaps not updating? And then in that case, we're getting Well, that would make that equal to that, which wouldn't end up doing anything. Unless it would, of course, because we have maybe we have some sort of funky thing happening where... let's try this. Let's bring back that one case. Let's bring back that one. Because that could maybe do something. No, render procedure. We don't want that. We want to bring back this. XMM4 is the far. Oh! Okay. Interesting. So, okay, I think that what we're doing is we are moving the ray inappropriately. The ray situation. The ray situation. And maybe that makes sense because, you know, when we trace it and we've calculated at our sample start, we calculate a ray origin. And then when we trace it again, well, when we're updating, no, that makes sense, yeah. Look from is now the position. The origin becomes track ray origin of closest T. This is now the ray origin of the closest T. And the ray origin is the transformed, yeah, and that makes sense. That is what we want to do. So now we're adding hit position. So we have a direction. This direction stays the same. Direction stays the same. Well, actually, the direction's been changed. Well, it sure should have been anyway. Oh yeah, no, that's it right there. That's the direction. And that's the closest T. 12 is closest to T. So we're multiplying the new direction. We're multiplying the new direction, quote unquote, new direction, by the extra sample is doing nothing for us right now, so let's just go back to one sample. One sample, please. So our new direction is XMM12. And the thing is, I did 12 we just don't care about anymore because we're restarting it. Yep. But we are adding, we're adding the direction times the nearest hit to our ray origin, which is at this point equal to the closest origin. The closest origin is XMM10. So we're adding the hit position, or rather we're adding how long it took us to get to, you know, we're adding this vector here to the origin. But, and again, this is without any movement of the origin. This is just with the one thing. Let's go back down here and let's change our, where's our thing? Thread count, sample count, bounce max, cube iterations is 1. Okay. So this is without any translation at all. Yep. Wait, how did we get rid of the reflection? I forget now. God, that's a bad thing to forget. Ah! Interesting. Wait, did I fix it? I don't understand. Did I fix it? That would be quite inconvenient because I really don't remember how I did so. Why is there 2 cubes? Because I said there was 2 cubes. I see. Hello. Still no nothing. Still no nothing. What did I just do? For real? What have I done? Oh, okay, I brought this back. Okay, so that means this. That means we may have been going too far, or that we were reflected along this boundary. Yeah, is there any possibility, 1, 2, 3, that we got reflected to down here, and then all of a sudden, here we are? Or something like that. So let's bring that back to the center. Well, I mean, at this point, I guess let's just see if this works with 3 of these. Or at least see what happens. Only 2 bounces max, it should be noted. That's wrong, Colin. Okay, something's pretty damn funky still. Pretty damn funky. Whatever it is, it means that when we were up here before, there was a situation in which I believe we must have been getting reflected down here. So that's interesting. That means that were just going too far and we weren't actually getting reflected or something. Well, okay, here's an interesting question. Okay, what if it was this? What if instead of that, we were getting reflected and then moved? Or not moved, and then we were faced the other way. And then it was back the other way. Maybe even we were being moved, because then that would actually make sense. Okay, so then let's go to, because we would be being moved this distance, actually. So then that would just mean that we did something before, like we changed the value of something before. I just need to get this into my head here. Trace ray. So we're tracking the blah blah blah. So we do a reflection. We get the new direction. Okay, so we calculate the hit position. We calculate the hit position after we reflect the ray. So then what's happening is, again, we have our T. Are we able to do this? This is my question. We just used, we're overriding 12 here, but it doesn't look like we used 12 up here. We are overriding 10, and it doesn't look like we used 10. Let's see if we can just do this right here. Okay, interesting. That fucks us up in an odd way. Doesn't that just rub you the wrong way? Let's do sample count. Let's do 16 samples. See what happens there. They're kind of odd. They're fucked up. They're kind of cool looking, but they are fucked up. Of course, it kind of makes sense that we're seeing black up here. Now we should see green. This is obviously wrong, but we should see green on the bottom. And we don't. Okay. All right, so we're updating our XMM11 is our ray direction, times our T near. Where are we getting our T near? Rather, is T near, has it been splatted? It has. Interesting question, though, because it hasn't been splatted on, yeah, it has. It has. Oh, interesting. Huh. It looks interesting. It looks quite weird. Okay. Okay. So I wonder why 12 and 3 are different here. Because as far as I can tell, they should be the same. 12, just to be clear, is... I really should just stay down here on this one. And 12 is going to be... 12 is closest intersection T. Maybe v3 norm just screws with number 3. Ah. Pretty weird. What's our max bounces? That's a question. 16. What if I do more? I see. Well, no. Well, no, well, no, well, no. Whoa, interesting. Okay, what did I just do that made that happen? Something funky going on here, that's for sure. interleaved shuffle of quadruplets. Source control. 1, 1, 2, 2, 3, 3, 4, 4.
Yes, it should work. Why?
Greater than, less than. JB. Jump short if below CF equals 1. Okay, interesting. Cube iterations is doing it to us. I'm going to go ahead and look at my hand moving.